Before I introduce the rational zero test, I would like to talk about linear factorization theorem. Suppose we have a 6-degree polynomial. 6-degree polynomial means the highest degree, the highest exponent you see is 6. Let's take a look at this example. We have f of x equals to x to the 6 minus 3x to the 5th minus 41x to the 4th, and then you have your third power, second power, first power, and then a constant. If you factor this 6-degree polynomial correctly, you are going to get the following. So we have a 1, so this 1 stands for the leading coefficient. The leading coefficient of x to the 6 is equals to 1, so we factor out 1, and then we have x plus 1 times x minus 2 plus x times x plus 3 times x minus 4, and then times plus 5 minus 6. How do I know that this is right? So the first thing that you can check is you have 6 parentheses, right? So when you fully expand that, you have x times x times x, follow my cursor, times x times x times x. So you are going to get x to the 6, right? So the highest degree that you will get is x to the 6. Each parenthesis is a linear factor. How come I said linear factor? Because they are all x raised to the first power. So if you have a 7th power, then you are going to get 7 parentheses. If you have a 20th power, you are going to get 20 parentheses. If you have a 51 degree, then you are going to get 51 parentheses. In general, suppose we have an nth degree polynomial, we say that f of x is equals to a to the an means the leading coefficient, and then x minus c1, and then multiply c2, c3, and then all the way to cn. And then c is a complex number, either real or imaginary. So if you don't want to think about complex number, you don't want to make this super complicated, you don't want to confuse yourself, here is what I suggest you to do. Just think about a 6 degree. Just think about the example I gave you. So for 6 degree, you have a product of 6 parentheses. Each parenthesis is a linear factor. If you have a 21st degree, then you are going to get 21 of this. You are going to get a product of 21 linear factors. Alright, so that is what I want you to think. So for nth degree, you are trying to factor a nth degree polynomial into a product of n linear factors. So the example I gave you is f of x equals to x to the 4th minus x to the 3rd minus 5x squared plus x minus 6. I would like you to factor this first, factor this 4th degree polynomial, and then set that equals to 0 to find the 0 of this function. What is 0? What is 0 means? 0 of a function means the x-intercept. When x is equals to this number, y is equals to 0. So that is what do I mean by 0. And then using rational zero test. What do I mean by using rational zero test? Look at the 6-degree polynomial one more time. So without any strategy, are you able to factor a 6-degree polynomial to this? How long does it take? That will probably take a long time, right? I give you a 6-degree polynomial, and then I give you 6 parentheses to fill out. That is going to take you a full day to do it. But using rational zero test, that is not going to take a long time. So the very first step in rational zero test, this is new to everybody, is you have to find the possible rational zero. So the possible rational zero, you have to memorize this, is the factor of a constant divided by the factor of a leading coefficient. Constant is -6. Leading coefficient is equals to 1. So what do I mean by factor? What number times what number is equals to 6, which is 1 and 6, right? So you would write plus or minus 1 and then plus or minus 6. And then you are going to ask me immediately, hey, why do you include the negative? Because you have a -6, right? So it can be positive 1 times -6. It can be -1 times positive 6. That's why you want to include the negative and positive. And then also you want to include the 2 times 3. And then that's it. And then the factor of 1 is very easy. It's just the 1 itself. And then what do I mean? Why do I still have an equal? I am looking for possible rational zero. Rational means fraction. So you will be taking each number on top divided by the number on the bottom. So that is I should go back to orange. 1 divided by 1, so you have a plus or minus 1. 2 divided by 1, plus or minus 2. 3 divided by 1, plus or minus 3. 6 divided by 1, plus or minus 6. So what does that mean? Why do we have to do this? So now we got this list. So what that means is when you try this one by one, so you are going to try f of -1 and then you will try f of 1. So if you keep on going, how many numbers do we have? We have 8 numbers, right? Plus or minus 1, 2, 3, 6. So you are going to keep trying and then you will reach to a number. So in this case is f of 2 that is equals to 0. So that proves that x minus 2 is one of the factors. Okay, we have a few things to talk about in here. So f of 2 is equals to 2 and here is your first question mark. Hey, on the test, I don't have much time. So what if I have to try like 8 numbers to reach to the first 0? Yes, you will have to do that in theory, but in my class when I create an exam problem based on the rational zero test, I will just provide maybe 3 numbers. So I will just say hits, use this list, and I will just give people like 3 numbers to try, and then usually I will just put the one that they need in the second number. So once they try the first number, that is not going to work. Once they try the number, they will get a 0 and then they can do the next step immediately. So in my class, I will just give you a few numbers to try, then you do not need to try the entire list. Because think about this, what if this is a 60 instead of 6? If this is a 60, then this will be extremely long and then you will have many numbers to try. So on the test, number 1, I will try to keep these numbers small. Number 2, I will give you a hint to help you. All right, and then your next question mark is, hey, all right, I get it, f of 2 equals to 0, but I don't get this part. X minus 2 is one of the factors. Hey, what is this? Okay, let me explain that to you. So let's go back to the 6-degree polynomial, plus 1 minus 2 plus 3. So look right here. So what happened when I set that equals to 0 to solve for x? What do I get? Set the whole line equals to 0 to solve for x, so we get x equals to -1, x equals to +2, x equals to -3, +4, -5, and +6. So we get x, when you set that equals to 0, this gives you x equals to +6. Now, continue. When you plug in x equals to +6 to this polynomial, do we agree that that is equals to 0? Let's do that one more time. You set this equals to 0. One of the zeros is x equals to 6, right? So that means when x is equals to 6 right here, you plug in the 6 to the x, you are going to get a 0. So that's why in this problem, you know that f of 2 is equals to 0. So f minus 2 is one of the factor, because when you factor this into 4 linear factors and then set that equals to 0, that this gives you x is equals to 2. That is why. Now, what that means is f of x is equals to x minus 2. That also means f of 2, one of the factor, that means x times 2, and then you multiply something, then you will get to the 4th degree polynomial right here, right here. So the 4th degree, so you must have an x to the 3rd and then something right over there. So at this point, just for the trying, I know that one of the factor is x minus 2. So you don't have to sit in on your table and then try this the entire day. And then what is the next step? The next step is I will be taking the given polynomial divided by this to get this. Think about this. 4 times 3 equals to 12. That means 12 divided by 4 equals to 3, right? So I am going to take the given polynomial divided by x minus 2, and I will use synthetic division, because in rational zero test, people use synthetic division. So for synthetic division, you have to you have to drop the coefficients down. So x to the fourth is 1, x to the third, the coefficient is 1, the second power is -5, first power is 1, and then the constant is -6. And then this is a x minus 2, the number is always the opposite. You pull the 1 down, 1 times 2, 2 plus 1, 3 times 2, -5 plus 5, 3 times 2, funny, 6. -5 plus 6 is equals to 1, 1 times 2, 1 plus 2, and then 3 times 2 is equals to 6, so you have a 6, and then -6 plus 6, this is equals to 0, so this is a remainder. So remainder equals to 0. What that means is x minus 2 is a factor. If you don't understand this, so let me give you something real quick. So let's say 12 is equals to 3 times 4, right? And then 12 divided by 3 is equals to 4 and no remainder. That means 3 is a factor. If there is a remainder, then 3 is not a factor. And then how about the rest? The rest is the quotient. Coefficient of the quotient. So you have a constant, and then you have a first power, and then you have a second power, and then you have the third power. So this is the quotient. So what that means is f of x is equals to, so this x minus 2, you got the x minus 2 right here. You just try all these number to get the first factor, and then you have x to the third plus 3x squared plus x plus 3. Do we agree that from compare this to the given problem, we just get a factor, right? And then you keep on trying, and then the next step is you just try that f of -3 is equals to 0. You just have to keep on trying. So what that means is x plus 3 is a factor. And then you will take this right over here, and then you will perform another synthetic division that is 1, 3, 1, 3, right? And then x minus 3, and the factor is x plus 3, then this will be a -3. Then you will have to put a -3 right over here, pull the 1 down, 1 times -3, add them, 0 times -3, 1 plus 0, 1 times -3, -3 plus 3, that is equals to 0. So this one is remainder equals to 0. So what that means is x plus 3 is a factor. Okay, what do we have left? This one is the constant, and then first degree, and then a second degree. We are almost done. So now, from this point to this point, what did we do? First of all, I have a polynomial for you, and this is the given polynomial, x to the 4 plus x to the third minus 5x squared plus x minus 6. This is what I gave you. And then at the very beginning, we figure out the possible rational zeros right here, the blue and green. And then we try everything in this list. We try everything in this list, and then we found that f of 2 is equals to 0. So x minus 2 is a factor, and then we perform a synthetic division. So the synthetic division is right over here. You take that divided by x minus 2, then you get x to the third plus 3x squared plus x plus 3. And then you take that x to the third plus 3x squared plus x plus 3, and then you divide it by the next factor, which is x plus 3. At the end of the day, you have x squared plus 1. Now, let's summarize everything. So f of x is equals to x to the 4 plus x to the third minus 5x squared plus x minus 6. This is what I gave you. The first factor you found is x minus 2. The second factor you found is x plus 3. And then what else? And then you have x squared plus 1. And then unfortunately, this is not a linear factor because there is no way to factor x equals to -1. So this is factorization. Factor form. I will just say factor form. to make the name simple. Factor form, factor form. And then how do we get the 0? So all you have to do is you set that equals to 0 and then you solve for x. So as a result, x is equals to 2 and x is equals to -3. So you have x squared plus 1 equals to 0. I know this cannot be factored. X squared is equals to -1. When you take the square root on both sides, the square root of -1 is equals to I mean plus or minus. Do you know why do we have to use a plus or minus? When do we use a plus or minus? When the degree is even. So you have to use a plus or minus -1, and then that is equals to plus or minus I. This is in complex number. So plus or minus I means not real zeros. That's why at the very beginning, I said that C is a complex zero. So this is a complex zeros. Okay, so when you graph this, what do you see? Here is the graph of the given function. Do you see this? These are the zeros, right? So these are the 0, which is the x-intercept, 2, 0, and -3, 0. Do you see that we have a -3, 0, and then a 2, 0, right? And then what else? Where is the I? Do we see the I? Nope. We have 2 real zeros right here. One at 2, one at -3. That's it. We have 2 x-intercept. That's all we have. How about the I? The I is a complex zero. You will not see that on the graph. All right, so that is the rational zero test. So for rational zero test, all you have to do is you figure one out. So you figure one of the factors out using the try. You try every single number, and then you find one factor. You perform synthetic division to reduce the polynomial from 4th degree to 3rd degree, and then you find another one, perform synthetic division, reduce the polynomial from 3rd degree to a 2nd degree, and then you can draw a conclusion. So at the very beginning, you divide it by the first factor, you get your 3rd degree, take the 3rd degree divided by the next factor, you have your 2nd degree. This cannot be factored, then you just reach to our solution. And then here is the factor form. You set the factor form equals to 0. Using zero product property, you can find the real zeros and the complex zero. Sometimes there is no complex zero. All right, that is the end of this problem. It's a little bit long, many steps, but if you do a little bit of practice, you should be able to do it very smoothly. All right, if you like the way I explain rational zero test, give me a thumbs up, a subscribe, and I will meet you all in the next video. Take care.